everybody wonders about Pluto. I mean, it's this extraordinary world with regions of dark terrain and light terrain, and there's even nitrogen snow. Today, we have an extraordinary revelation that will leave you speechless. Bill Nye the Science Guy has just dropped a bombshell about Pluto that NASA has been keeping under wraps for years. What incredible secrets has the space agency been hiding on this distant dwarf planet? Join us as we dive into Bill Nye's stunning claim and uncover the astonishing discoveries that NASA has finally revealed. Buckle up, because this is a journey through space you won't want to miss. Every innovation in modern technology opens another chapter in the story of our space exploration adventures. Looking back, we have no doubt made giant strides forward in our space missions since Neil Armstrong set foot on the moon. Still, the vast cosmos and our inability to fully unravel all the mysteries of the universe are constant reminders that there is so much we need to learn. This is where NASA's innovative projects and instruments come in. The James Webb Space Telescope, JWST, was launched to unveil distant worlds and peer into the origin of the universe. Most importantly, this equipment is a monumental extension of NASA's previous missions. The excitement of understanding cosmic mysteries of the past is an epic adventure. We are still curious about the Big Bang, the formation of our solar system, and, more importantly, we strive to find a definitive answer to the possibility of alien life outside our home planet, Earth. Could our knowledge of the solar system evolve into a new field of study? Will the new information gathered through the James Webb Telescope force us to reconsider our fundamental views of the universe? These questions prompt a review of our current knowledge, especially our understanding and classification of Pluto as a dwarf planet. Thanks to the New Horizons mission and its groundbreaking discoveries, we've been able to learn more about Pluto. The billion-dollar investment has revolutionized NASA's efforts and expanded our understanding of the icy planet. Before the New Horizons mission, our knowledge of Pluto's surface was limited. The most detailed image we had, taken by the Hubble Space Telescope in 2002, revealed a mysterious mix of colors on Pluto's surface. These colors included shades of orange, white, and black, along with a bright spot that caught scientists' attention. Given the few details offered by the Hubble Space Telescope, investigating Pluto was similar to trying to solve a puzzle with only a few jumbled pieces. Then the James Webb Space Telescope appeared on the scene. It journeyed into Pluto's orbit, taking several stunning pictures that gave scientists a whole new understanding of that planet. The telescope caught a glimpse of Pluto's surface, the craters, the plains, and the mountain peaks. All of the planet's features were present in the finest details, showing traces of its geological history. The scene was like being granted a VIP backstage pass to a magic show and finally being able to see all the amazing things that had been hidden from us. These pictures not only fascinated scientists but also captured the imagination of many people around the globe. It ignited a new wave of curiosity and passion for the unknown regions beyond our planetary neighborhood. In July 2015, the New Horizons mission accomplished its primary goal. The spacecraft flew past Pluto and its many moons and sent back the first detailed pictures of this celestial body to Earth. This moment in history has turned out to be an important step forward in space exploration. Astronomers obtained data about Pluto and its moons that they previously didn't have. The success of the New Horizons mission opened other avenues for NASA to explore the vast expanse of the Kuiper Belt. Recognizing the urgent need for a solid understanding of distant celestial bodies, NASA set its sights on planets situated between Neptune's orbit and nearly 50 astronomical units, AU, from the Sun. The single most striking event of the mission was definitely the close flyby with the planet Pluto and its biggest moon, Charon. Additionally, New Horizons captured clear images of Pluto's four other moons, Nix, Hydra, Kerberos, and Styx. The process of data collection took 15 months, and by October 25, 2016, the goal was achieved. The spacecraft successfully collected 6.25 gigabytes of valuable information. But what is the importance of this huge amount of information for NASA's understanding of the dwarf planet? After data collection, the findings from the New Horizons mission were so unique and distinctive that scientists had to create new high-tech data models to interpret the results. In time, it became clear that Pluto was subjected to dramatic surface and atmospheric variations, which contradicted initial expectations. Despite its reclassification as a dwarf planet, Pluto displayed a dynamic nature. It evolved at a rate that prompted NASA to reassess and revise existing knowledge about this intriguing celestial body. NASA's high-definition pictures of Pluto reveal fascinating details about this distant dwarf planet. One striking feature is Pluto's heart-shaped region, aptly named the Heart of Pluto. This geological phenomenon, scientifically termed the Sputnik Planitia, plays a major role in shaping many of Pluto's surface features. Surprisingly, this heart-shaped region is not warm and beating, but rather cold, icy, and almost frozen. In fact, it's a vast expanse of nitrogen ice spanning over 1 million square miles. The presence of this enormous nitrogen glacier at Pluto's heart has significant implications. It is responsible for a process called true polar wander, which causes the planet's spin axis to shift. Before NASA's mission, scientists were unaware that Pluto's heart-shaped basin sits opposite its largest moon, Charon. This reorientation of Pluto has intriguing consequences, particularly regarding the relationship between Pluto and Charon. In simple terms, the alignment of Pluto's heart-shaped basin with the tidal axis between Pluto and Charon suggests that the heart's presence has an influence on the planet's orientation. This means that the gravitational pull between Pluto and Charon, coupled with the presence of the Sputnik Planitia, has caused Pluto to tilt slightly on its axis. This newfound understanding sheds light on why Pluto is such a dynamic and intriguing world. Despite being uninhabitable for humans, Pluto's icy surface and the massive nitrogen glacier at its core contribute to its unique characteristics. This includes its tendency to tip due to the imbalance in its mass. Pluto's huge mass, coupled with the gravitational pulls of its moons, can trigger a phenomenon known as true polar wander. This phenomenon happens when a planet aligns its axis of rotation with a more favorable orbit. However, the presence of the thick ice sheet alone isn't sufficient to cause such a significant reorientation. While the massive ice glacier contributes to Pluto's mass, it is not the only factor driving the dwarf planet's tilt or the strong tidal forces it experiences. In a remarkable turn of events, recent technological advancements have allowed scientists to delve deeper into Pluto's mysteries, leading to a groundbreaking discovery. Unknown to us, Pluto has a sea hidden beneath its icy skin. This is a revolutionary discovery, as it overturns our previous scientific assumptions about the planet's structure and origins. The existence of an ocean as one of Pluto's internal features radically alters our view of this distant moon, placing it among other oceanic moons in the solar system like Titan, Enceladus, and Europa. Although there is currently no evidence that life could exist in Pluto's ocean, the fact that it may even exist makes us question whether extraterrestrial environments could be habitable. This discovery provides grounds for consideration of life beyond Earth and heightens the stakes for studying and finding oceanic worlds in our solar system. NASA also acknowledges that, despite the absence of conclusive evidence, extraterrestrial life remains a viable hypothesis. Another relevant discovery through NASA's Cassini mission was an ocean rich in phosphorus detected below the icy surface of the Enceladus satellite orbiting around Saturn. This finding ignited continuous discussions about the possibility of extraterrestrial life since phosphorus is vital for the formation of DNA and RNA, the constituents of the molecular basis of life. Although Enceladus remains a potential astrobiological target for space research, the complexity of assessing the habitability of Pluto takes a different turn. Pluto's case is different because while the imaging equipment is advanced enough to take clear pictures of its surface, they are not equipped to probe into its habitability. The failure to determine the exact chemical composition of Pluto's subsurface water makes it impossible to expand our knowledge and conclusively determine if Pluto can host life. NASA continues to invest in exploring icy worlds like Pluto, but presently, the equipment for estimating the nutrients of its oceans is non-existent. However, this doesn't diminish the value of studying Pluto. The planet offers insights into various aspects of planetary science, from understanding its geological features to unraveling its origins and evolution. Each new discovery adds to our knowledge of the solar system and fuels our curiosity about the possibility of life beyond Earth. When we delve into the high-resolution images of Pluto, we uncover a multitude of hidden features, some of which may astonish you. Among these discoveries is a lake nestled within a mountain range just west of Pluto's iconic heart, measuring approximately 20 miles wide, equivalent to about 32 kilometers. This strange body of liquid now appears frozen. However, clues scattered across the dwarf planet's surface hint at its past existence as a flowing lake brimming with a mysterious substance. The existence of a lake on Pluto is even more astonishing because it is located in the extreme cold, with temperatures of up to -230 degrees Celsius or -382 degrees Fahrenheit. Although it is unclear exactly what the liquid was made of, scientists suspect that it might have been liquid nitrogen. It is speculated that billions of years ago, liquid nitrogen may have been responsible for the carving of riverbeds and complex gullies, such as the beautiful landscape shown in the photograph. The ability of liquid nitrogen to pool and flow on a world so distant from the warmth of the Sun is attributed to Pluto's fluctuating surface temperatures and pressures. As the dwarf planet orbits closer to the Sun, its surface undergoes subtle warming, causing nitrogen ice to transition from solid to gas. Under specific conditions, this transition may also lead to the formation of liquid nitrogen, giving rise to these unexpected features. Pluto further displays another enigma as scientists look into its hazy atmosphere, clearly illustrated in the images received. While Earth's atmosphere differs significantly from Pluto's, the composition of gases enveloping the distant dwarf planet adds to its allure and complexity. It offers scientists invaluable insights into planetary atmospheres and the broader dynamics of celestial bodies in our solar system. Pluto's atmosphere is incredibly thin, about 880,000 times thinner than Earth's atmosphere. It's believed to form when sunlight vaporizes surface ice, leading to a reaction with methane and other molecules. This reaction produces a complex mix of hydrocarbons, resulting in a smog-like haze. These haze particles, which scatter blue light, settle down through the atmosphere, forming intricate horizontal layers that extend to altitudes of over 120 miles or 200 kilometers. With Pluto getting farther from the Sun every 248 years, its atmosphere continues to freeze, inducing a type of snow which falls and sticks to the surface of the planet. However, the specific nature of these snow particles is still a mystery to us. Scientists are still unable to determine if the snowfalls are grainy or flake-like. There's also a possibility that this snowfall could manifest in the form of blizzard-like winds or a soft snow moving around the dense cold fog. So far, scientists have been able to observe what appears to be a layer of nitrogen snow that condensed from the atmosphere and settled on the surface in regions like Tombaugh Regio. Hopefully, this will help scientists identify the kind of snowfall that rains on Pluto. While investigation continues, one of the most striking features on Pluto is its snow-capped mountains in the southern hemisphere, reminiscent of the Alps on Earth when viewed from the International Space Station. However, upon closer inspection, these mountains are markedly different. They are composed of water ice, frozen as hard as granite, and covered in a type of frozen methane snow. Some of these towering peaks can reach heights of up to 2.2 miles, or 3.5 kilometers, above the surrounding terrain, similar to the Rocky Mountains in North America. While seeing mountains on Pluto isn't shocking, scientists are unable to explain how these mountains are formed. On Earth, the origin of the mountains is essentially the result of either tectonic movements or volcanic activities. Meanwhile, the mountains on Pluto show no evidence of tectonic or volcanic activities. As such, scientists propose that its mountains are formed through a process called sublimation erosion. Sublimation erosion occurs when the frozen materials, like nitrogen or methane on Pluto's surface, are exposed to sunlight and transformed directly into gas, leading to erosion of the surrounding terrain and leaving behind tall, spiky peaks. Remarkably, Pluto apparently regenerates its surface in some regions. Evidence suggests that a cold, slushy lava-like substance has flowed over its landscape at various times. This unusual phenomenon is called cryovolcanism, where the icy volatiles, such as water, methane, and ammonia, are erupted instead of lava. The same cryovolcanic activity is also seen on some other icy moons, like Enceladus and Europa. The presence of mountainous regions with pits or depressions on their surfaces points to the cryovolcanic activity of Pluto. One compelling example is Wright Mons, a mountain in Pluto's southern hemisphere rising 2.5 miles, 4 kilometers, above its surroundings, with a wide summit depression. This feature, seen in close-up images, is suspected to be an ice volcano, potentially the largest of its kind in the outer solar system. Another intriguing discovery on Pluto's surface is the extensive fields of dunes, resembling those found in deserts on Earth, stretching across the western edge of its heart-shaped region. These dunes are another mystery that needs to be solved. To study extraterrestrial areas where people have not yet set foot, the features on Pluto's surface, including its dunes, are similar to those found on Earth. The dunes on Earth are formed by the movement of wind that carries particles and deposits them in specific areas. However, the dunes on Pluto exhibit unique characteristics. They may have formed not only from wind action but also from the melting of nitrogen ice, causing sand-sized methane ice grains to be lifted by rising gases and then carried away once airborne. Moreover, Pluto's dunes are significantly larger than those on Earth, with some as tall as mountains and stretching for many miles. This is likely due to the lower gravity on Pluto, allowing particles to be transported more easily, creating these impressive features. Another intriguing aspect of Pluto's landscape is the presence of iceberg-like structures scattered across its heart-shaped region. These structures appear to be fragments of ice that have broken away from larger formations. Each fragment measures 1 to several miles wide and seems to float across the frozen surface below. Scientists believe these icebergs consist of frozen water since water ice is less dense than nitrogen ice. When they break off and are pushed into Pluto's heart, possibly through glacial flows, they are subject to the motion of the nitrogen ice below, resulting in the peculiar shapes observed in this region. The cell-like formations covering Pluto's heart also reveal information about the planet's geological processes. These formations, resembling a process called convection, occur when a fluid is unevenly warmed, whether by the sun or a boiling kettle. This convection process is believed to be a signature of Pluto's dynamic and ever-evolving surface, shedding light on the complex interplay of forces shaping this distant world. The presence of convection on Pluto suggests that something beneath its heart-shaped region is warmer than the surface, causing the frozen nitrogen plains to slowly move over the years. By closely examining the images, scientists noticed that the icebergs tend to gather around these convection cells and are likely being pushed to the edges by the underlying forces. Scientists continue to study these formations and other characteristic features of Pluto, hoping that soon they will have answers to the hazy questions about Pluto. Each time we gaze upon Pluto, it seems to offer something new to discover. And Pluto is just one of potentially hundreds of dwarf planets in the Kuiper Belt. It's truly awe-inspiring to think about the wonders that may exist on other dwarf planets, like Haumea, Makemake, or Eris, which we haven't yet had the chance to explore. Hopefully, one day in the future, we'll have the opportunity to witness their frozen beauty and unlock the secrets they hold. With the launch of the James Webb Space Telescope, we stand at the brink of a new era in space exploration. Pluto's designation as a dormant planet is quickly becoming a relic of the past as NASA unveils clear, detailed images of sophisticated geological features that have recently emerged on its surface. These stunning pictorial references mark a significant breakthrough, hinting at the dynamic nature of this distant world. It's remarkable to think that just a few gigabytes of data can unlock a world of endless possibilities for us. The wealth of information gathered by missions like New Horizons and the James Webb Space Telescope offers new glimpses into the mysteries of our universe. With each new discovery, we inch closer to understanding the complexities of celestial bodies like Pluto and uncovering the secrets they hold. Indeed, the prospect of what lies ahead in our exploration of the cosmos is both thrilling and awe-inspiring. As we continue to push the boundaries of our knowledge, the journey into the depths of space promises to be as fascinating as it is enlightening. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing content like this one.